Alright guys, welcome back. In this video I'm just going to spend a few minutes going over some basic circuit terminology. I'm going to discuss things like branches, loops, nodes, elements, and that kind of thing. So let's pull up a circuit diagram, something like this. If you've been watching the previous videos, then some of these elements might look familiar to you. Starting on the left hand side, this is one of the symbols that we can use for voltage sources. Now, voltage sources are things like batteries or generators, and basically what they do is they provide a constant voltage between their negative and positive terminals, and they'll do that by using as much current as possible to ensure that that voltage difference is always the same. Down here we have a current source, and what current sources do is they basically just ensure that a constant amount of current is flowing through this branch, and they're going to do that by using as much voltage as necessary to ensure that that current is constant. And the rest of the elements in this diagram are all resistors. So when we look at this diagram, we have 1, 2, 3, 4, 5, 6, 7 elements, and everything else is basically just a wire. Now we define a node as any region between circuit elements, which to us is basically just the sections of wire, because the wires are considered electrically common unless they're interrupted by another element. So what we can do is we can color on some nodes here. So let's color on the first node here in blue. It's like this. So everything that is shaded in blue is one node. We can color on another node here in red, and then one more in green, and then another node here would be this pink one, and then we have one last node over here that we can color a different color. So looking at this diagram, we have 1, 2, 3, 4, 5 nodes. And if a node is a region between circuit elements, then branches are things that come off of nodes. So if we look at everything that comes off of the blue node, we have 1, 2, 3, 4 ways out of that node. So we would say that there are 4 branches coming off that node. In total, when we look at a circuit, the total number of branches equals the number of elements in the circuit. So we have another one right here, and another one here, and right here. And if we count those up again, 1, 2, 3, 4, 5, 6, 7. So this circuit has 7 branches. Alright, we also talk about loops in circuits, and loops are basically just, like it sounds, like complete loops that we can go around in circles. So if you pick a point somewhere, let's start here, we can go in a circle like this and get back to the original point. So that is one loop. We can start here, we can go around and get back to our original point. That's another loop. You can go counterclockwise as well. The direction doesn't really matter, it's just that it is a continuous circle. We have another loop here, starting at this point, going around, and we can come back. We have a big loop that goes the whole way around the outside, starting here. You can go all the way around, back to that point. And then we have another loop that is somewhere in the middle, so we start here. We can go all the way over to here, down, over, and back. And then there's one more loop. We could make this full circle here that goes around these 2 smaller loops on the right side. So if we count up all of the loops in this circle, we have a total of 6 loops. Alright, let's move this over and give ourselves a little bit more space to work with. And to just briefly mention what happens if we have like junctions of wires, because this is a pretty clean circuit diagram, but you might have ones that are a lot more complicated with crossovers. So if you have a situation where there are some wires meeting at a point like this, then if they're all connecting here, right at this point, then these would form one single node. You can either have it with a dot or without. Both of those would basically indicate that this is one node. But if you had another type where you have a wire like this and another wire crossing past it without actually making a connection, then we would have 2 different nodes, and we draw that with a little hop like that. So the top diagram, this would indicate one single node, and then the bottom one here would indicate 2 different nodes like that. So as far as everything else that we're going to be seeing on circuit diagrams, if we just have a straight line like this, this represents a wire. And where we have the zigzag line, as in this diagram, these are our resistors. Now for independent voltage sources, we have a symbol like we have in this diagram, which is the circle with the plus and minus, but we can also have one that looks like this that I've been using in the previous videos with sort of alternating long and short lines. And how we also have in the diagram, we have an independent current source, which we just use the circle with a line in it. Now basically for the independent sources, they're going to provide a stable voltage or current at all times, no matter what else is going on in the circuit. But we can have other elements like a dependent voltage source that's going to give a certain voltage depending on some other condition in the circuit. And to do that, we draw it more like a diamond shape, like this, with the plus and minus inside. And same for a dependent current source. It's this diamond shape with an arrow. And it's going to give a specific current based on some other condition in the circuit. So we're also going to see capacitors later on, and we use this symbol like this, like two lines that are the same length with a little gap in between. And these are passive elements that store energy in an electric field. We also have inductors. It's kind of this like squiggly thing. And these are passive elements that store energy in magnetic fields. You'll see this symbol here for ground. Now ground can mean a few different things, but generally it's like a reference point from which the other voltages in the circuit are measured from. Sometimes we can talk about it as a common return path for the current to go back to the source. Or also, you might be familiar with it as a physical connection to the earth, where literally someone has a circuit and they bury like a piece of metal in the ground and connect it to the circuit at this point. That's done for safety reasons, and it basically is going to define the electric potentials or voltages throughout the whole circuit relative to the earth's conductive surface. But yeah, we also might later in the course run into these guys. This is an operational amplifier. And these are basically integrated circuits that amplify weak electric signals. They have two inputs in the way I've drawn it coming in from the top and one output going out the bottom. There's many different kinds of these, and we might get into these later in the course. But then basically, if we just want a generic element, sometimes you might just see a rectangle like this. And this can be used to represent any passive or active element that's in the circuit. So sometimes you might see these showing up and you'll be asked to determine like what it is, if it's passive or active, you know, dissipating or absorbing power or whatever. So yeah, you'll see those probably at some point, and they can basically mean any of these elements that we've drawn here. But yeah, I just wanted to make this video basically just identifying the names and the symbols that I'll be using in the rest of these videos, and also talking about the differences between branches, loops, and nodes, and that kind of stuff. So now that we've been over it once, then we can continue on with the rest of the videos in the series, knowing that we have this basic terminology down. So yeah, that's it for this video, and I will see you in the next one, and we'll go over Ohm's law.